Hi everyone, I'm going to go through a quick practice problem for this physics aviary, finding the specific heat capacity of a fluid. I do want to point out that you're going to need, you're going to need the heat equation, which we learned already. The heat that something loses or gains, this would be in terms of joules as its heat energy, is equal to its mass times its specific heat capacity times its change in temperature in degrees Celsius. So you'll need that equation, and we're going to actually use it twice in this problem because, as you can see, we have two objects. So it says determine the heat lost by your solid when it is placed in your liquid, assuming no heat escapes from the system. So what that means is when we put this solid, which you can see has a higher temperature than the initial temperature of the liquid, this solid is going to lose some heat energy, some thermal energy into the liquid until they reach an equilibrium temperature, which is going to be this 19.9 degrees Celsius. So we know that the solid is going to cool. In this case, it's magnesium. It won't always be magnesium. The solid's going to lose thermal energy, so it's going to go from 57 degrees to 19.9 degrees Celsius. And that thermal energy is going to go into our water ethylene glycol mixture. And so the temperature of this glycol mixture is going to raise from 12 to 19.9 degrees Celsius. So listen, water ethylene glycol must have a higher specific heat capacity because its temperature doesn't change as much. It's going to gain all of this heat energy. It's going to gain that amount of heat energy that the magnesium loses, but its temperature isn't going to rise as much, meaning that it's going to have a higher specific heat capacity. So we have to set up kind of a table here. So I'm going to kind of split my screen, I think. I would suggest you set up a table. So we're going to look at our two materials. So we have the magnesium, and then we have that water ethylene glycol mixture. And we already know we have to solve for that specific heat capacity here, but the problem gives us the specific heat capacity of the magnesium. It's 1,050 joules per kilogram degrees Celsius. We know that the mass is 101.8 kilograms. The mass of our mixture is 176.2, and I'm sorry, that's grams, so we're going to have to convert that to kilograms. 172.6, wow. So to convert to kilograms, we need to just divide by 1,000 here. So this is going to be 0.1018 kilograms. And this one will be 0.1726 kilograms. So we don't want to use this number. We want to use this one. Then what else do we know? Well, we know the initial and final temperatures of both. So we can figure out the change in temperature of both of them. So the change in temperature for our magnesium is going to be its final, which is 19.9, minus the initial, which is 57 degrees. And so if you do that, so you're 19.9 minus 57. So listen, that's going to give you a negative number, which all that means is that our magnesium is cooling. Its temperature is cooling. There's the change in temperature of the magnesium. Okay, so we know that the water ethylene glycol mixture is going to heat. It's going to gain energy. So how much is it going to gain? So from 12 to 19.9, that's pretty easy to do in your head, right? That'll be 12 to 19.9, so 7.9 degrees Celsius. Okay. So we know the change in temperature, that's going to be positive. So if we use this equation to try to solve for the specific heat capacity, we aren't going to be able to, because we know we're solving for C for this mixture. And we have its mass and its change in temperature, but we would also need to know how much heat it's going to gain. So we can't just start here. We need to come back over to our magnesium side, because however much thermal energy the magnesium loses as it cools is going to be how much thermal energy the water is going to gain as it warms. So we do have enough information to figure out how much thermal energy the magnesium loses because we have its mass, we have its specific heat capacity, and we have its temperature change. So let's go ahead and solve for how much heat the magnesium loses, right? So we'll have 0.1018 times its specific heat capacity, which is 1050, times negative 37.1. Also, this is the first part of the problem that is being asked to solve on your physics aviary. Okay, so the heat energy that the magnesium loses is negative 3965.62 joules. Okay, so the problem actually says give answers as positive, so we will not put that in as a negative. So 3965.62. Okay, but we're not done yet. So now we can use that information. If this is how much thermal energy the magnesium loses, then this is how much thermal energy our mixture is going to gain. So I'm going to put that as positive. And now we can solve for our unknown. So we put this in for Q, 62. Put that in for the thermal energy that our water mixture gains, the mass of the water mixture. We're solving for C, and the change in temperature is 7.9 degrees. So I'm going to multiply these two together first. And actually, listen, there's a lot of ways you can do this in algebra, so I'm going to actually do this. So 3965.62 divided by these two multiplied. So I'm going to put that in parentheses. So 0.1726 in parentheses times 7.9. So it'll multiply those first, which is what we want it to do, and then divide. So the specific heat capacity of our mixture is 2908.33. 2908.33 joules per kilogram degrees Celsius. So we'll put that in here. 2908.33. Hit submit. And our calculations are correct. Hope that helps you guys. Let me know if you have any questions.